Hello, chicos. I should have done this earlier. We're in book 2, proposition 4. But I want to explain something to you in general about book 2, okay? Come here and look at this. Book 2 is about lines and properties about lines. And when you cut them, that there's certain properties about it, okay? And the way you prove things in book 2 is that on those lines you make the stuff you're talking about. So in the case we're about to do, you're going to say if you cut a line at random, then the square on the whole of that line is going to be equal to the squares on the segments and twice the rectangle contained by the segments. I'll do the prop in a second, but all of book 2 goes like this. Something true about a line, if it's cut, if it's done whatever, okay? Then you do that dibujo. You make this, in this case, you make the square on the line and you make the squares. You have to prove that they're squares after you draw them, okay? Then when you do that, all you do is say, well, look, these chunks equal the big chunk, okay? This chunk plus this chunk plus this chunk plus this chunk, that is to say, this chunk plus this chunk plus this chunk plus this chunk equals this big old chunk, because the whole is equal to the sum of the parts. Great. And then you do the trick. This is the big trick now. But this chunk is the square on one of the segments. And this chunk is the square on the other segment. You have to prove that. You have to prove it. And this chunk is the rectangle contained by the two segments. And this chunk is also the rectangle contained by the two segments. You have to prove that. It's not real hard, okay? So the way it does it, the proposition, the enunciation is about something true about a line, okay? If you do something to a line, this is going to be the case. Then you do the drawing, you make all, you do your proof, and then you show that the big chunk is equal to the parts, little chunks all added together, and then the little chunks are all equal to, or you name them, but this chunk is blah, blah, blah. You name it differently. I could call this big blue square, or I could call it the square on this line. You see that? So you prove something about the big blue square so that you can prove something about the square on this line. So that's it. A line, draw it, show that wholes equal to the parts, and then re-establish that those parts can be named by the lines, okay? So, one last thing. Remember, once you have a line, you necessarily, if you say I want a square on that line, it's going to be one square and one square only, because all squares, their sides are equal and they're right angle. So that's it. You're going to get one size of square on this line. Likewise, with the rectangle. Once you have these two lines, and if it's a rectangle, that is to say right angles, then you necessarily you just have one size of rectangle, okay? So that's it. Now I'm going to do proposition 4, but this little explanation was for all of book 2. Thank you. Bye.